spirit and eagerness in the hall this morning. As we move ahead with our sessions today, we continue to explore some of the most impactful developments in the world of drug discovery and molecular therapeutics. I would like to express our sincere thanks to the Ministry of Education, Government of India and Punjab University for supporting global initiative of academic networks, which brings globally renowned scholars and cutting-edge topics to our doorstep. Now I would like to welcome Dr. Aman Bhalla for the tutorial.
A very good morning to all present. Okay. So I just give a brief glimpse that what we have done and now what is the objective of today's lecture. So we have started with the need of the asymmetric synthesis. I guess you have a clue about that why we have to study about asymmetric synthesis. Once you know all about the initial definitions and the concept, then we move to the methods which are required for the synthesis. Okay. So the methods which we discussed yesterday, that is, one is the resolution, second one is from the chiral pool, third one is the enzymatic. Okay. So now the fourth one, which is the chemical synthesis starting from the achiral substrates. Okay. I guess you have a keywords with you. Clear? So for this fourth, that is the asymmetric synthesis using the achiral substrate, we have to study 4 generations. Okay. That generations which will tell you that how you are going to plan the asymmetric synthesis. Yesterday I showed you one reaction, that is asymmetric aldol reaction. How many number of products are possible in that? Can you just give me just number? 4. Very good. That is 4 products will be there. And what will be your objective and target as per the requirement? Okay. What is the requirement? That you want to attain all the 4 products in a pure and enantiomeric form. If any reaction planned and it is giving you exclusively one product out of 4, what will you categorize that reaction? It is enantioselective or enantiospecific? Enantiospecific. But if there is the percentage in that 4 molecule about the majority and minority, then we have to categorize that reaction as enantioselective. Okay. So these concepts already with you because they are required to study these generations, that how a asymmetric reaction can be performed. Okay. So asymmetric synthesis is possible only under the influence of chiral group or chiral auxiliary. They may be derived from the chiral pool, that is okay, but if you have to carry out asymmetric synthesis, chiral unit is required, because if there is no chiral unit, then it is a 2 dimension. Because in start, if you see my first slide, I shown that is chirality, that is 3 dimension in 3 dimensional plane, what is the arrangement. Okay. So depending upon how this influence can be exerted, 4 strategies have been developed for the asymmetric synthesis. Okay. Today we will only follow these strategies. So see very carefully For all the asymmetric reaction, whosoever is preparing for CSIR, NET, UGC GATE examination, this is the important component of asymmetric synthesis. Now your first generation is always related to substrate controlled. Okay, so I just say you have to remember only the keywords. I am not saying that you have to see the mechanism aspect, you have to just remember keywords, then it will be easy to understand. Okay, first generation, that is substrate controlled. Okay, now what is that? The chiral environment is present on the substrate. Can you see in your starting substrate any chiral unit? You have a CH3 and hydrogen. The CH3 is present above the plane and hydrogen is present below the plane. The chiral environment is present on the substrate and the formation of new stereogenic unit. Can you see in your product you got some new stereogenic unit where you have a methyl and OH. OH is above the plane and methyl is below the plane. So the chiral environment is present on the substrate and the formation of new stereogenic center is controlled by this. Now see, if you have to perform a reaction with cyclohexanone, what is cyclohexanone? 6-membered ring with carbonyl unit. As we discussed earlier, carbonyl unit is a planar sp2. So if you have to introduce any group on the carbonyl carbon, you have a possibility of 50-50%, either from the above the plane or below the plane. So in your starting substrate, you have already placed one chiral unit adjacent to the carbonyl group. Okay. Now you react it with methyl magnesium iodide, or we call it RMgX. तो आपने एल्डिहाइड एंड कीटोन के रिएक्शन पढ़े हुए हैं RMgX में. If you react with formaldehyde, you get primary alcohols. If you react with acetaldehyde, you get secondary alcohols, or if you react with ketone, you will get tertiary alcohol. So this reaction is very simple. क्या रिएक्शन होता है ग्रिग्नार्ड रिएजेंट के साथ कार्बोनाइल का? How this reaction is going to pursue? Have you checked the reaction? If I just write you are reacting with methyl magnesium X, okay, Grignard reagents. ये marker check कर देना. Now what is the reaction? What is the simple chemistry in this reaction? You say that this is your partial negative and this is your partial positive. You are bringing this negative to this carbonyl carbon and this polarity will drift to O negative. So your methyl is going to attack at the carbonyl carbon. This is the simple reaction of aldehyde and ketones. Okay. So when we are talking about the movement of this methyl group to this carbonyl carbon, we are moving it this. What will you get? RCO negative, methyl and H. ये जो MgX है, it will come to here, you will have this. Then you treat with water, you will get This is the simple reaction which we have studied in our +1 and +2. Now the question is a very simple question. When you are seeing this methyl group coming to carbonyl, you are seeing it in 2 dimension. Your blackboard is 2 dimension. But actually you have to imagine this carbonyl group is in the plane. When a methyl is coming, it can come from the upper side and it can come from the lower side. So the possibility is 50-50. But if you get a 50-50 both the enantiomer, that is your racemic product. Then what is asymmetric synthesis? कहाँ गई वो asymmetric synthesis? So then what you planned? Adjacent to this carbonyl carbon, either on this side and either on this side, you placed a chiral environment. Now can you see your substrate in carbonyl group? You placed a chirality where methyl is on above the plane and hydrogen is your below the plane. Now you bring the methyl group. अब आप प्रेफर करके बताइए कि जब आपके सबस्ट्रेट में अपर प्लेन पे मीथाइल ग्रुप है, लोअर प्लेन पे हाइड्रोजन है, जो आपका इनकमिंग ग्रुप है वो किसकी साइड से आना प्रेफर करेगा? फ्रॉम द साइड ऑफ हाइड्रोजन विच हैज अ लेस स्टेरिक हिंड्रेंस. So can you see in your product the methyl is attached from the side of the hydrogen? So what you have done in this reaction? If this chiral unit adjacent to your carbonyl group is not present in the substrate, you get 50-50 both the enantiomer. But what you have done? The chiral unit is placed adjacent to the carbonyl group. Now the incoming group will decide to come from the side which has a very lower steric hindrance. So that's mean the formation of pure enantiomeric chiral product is controlled by the presence of chiral unit in the substrate. So that's why it is called substrate control. So if anything is present in the substrate which will help you to lead to the formation of only one type of enantiomer or a product, then that is your substrate controlled first generation reaction. Clear हुआ? That now it will be asked, what do you understand by first generation? तो आपको क्या कहना है कि there must be some chiral unit present in the substrate which will guide the incoming group to attack on the substrate, because the incoming group will only depend upon the presence. Now just imagine this is our seminar room. We have two doors. Now if I am inside, I have closed this room. Now I am controlling it, that how anybody can enter to this seminar room, I am controlling it. Okay? But if I am not here, you people are sitting, both the doors are open, anyone is coming, you don't have to say anything. They are entering, they are sitting. But as soon as I arrived here, I don't want that anybody should come here because he or she may disturb me. So I just locked it. Now who is controlling the coming of the students into the seminar room? Right? So in a similar way, if in your substrate no chiral unit is present, carbonyl group is lying in a plane, then the incoming group have a preference to coming from the upper plane or from the lower plane. So that means 50-50% possibility you are going to get racemic mixture. Okay, but if you want to get enantiomer specific reaction, you must have some chiral unit or chiral auxiliary which is present on the substrate, which will control the formation of the product. So can you see that in reaction scheme we have seen S with G. G is your chiral directing group. The reagent you are using a chiral reagent, methyl magnesium iodide is a chiral, इसमें तो कोई आपकी chiral unit नहीं है. So फर्स्ट जनरेशन तो क्वेश्चन आपको ऑब्जेक्टिव और ऐसे प्रिपेयर हो जाता है कि इफ योर substrate has a chirality, it belongs to what generation? So the first generation is your substrate controlled. Okay, now if you see the chirality is induced intramolecular. आपके सबस्ट्रेट में chiral यूनिट थी, उसने इनकमिंग ग्रुप को गाइड किया और आपके प्रोडक्ट में एक नई chiral यूनिट आ गई. So this is occurring within the molecule. So that means it is intramolecular. The question comes, first generation is intramolecular and intermolecular. आपको इंट्रा और इंटर का डिफरेंस क्लियर है? इंट्रा इज विद इन द मॉलिक्यूल, इंटर इज बिटवीन द टू. ओके, नाउ व्हाट इज द ड्रॉबैक? नाउ यू कैन सी इन होल स्लाइड इन रेड कलर it has been discussed. What is? However, the enantiomerically pure starting materials with appropriate configuration may or may not be available in chiral pool. अब आपके सबस्ट्रेट में जो chiral यूनिट प्रेजेंट है, ऐसा सबस्ट्रेट अगर आपके पास अवेलेबल ही नहीं होगा, will you go with first generation? So first generation की कंडीशन क्या है? That you must have a chiral unit in your substrate. But if your substrate are not available with variety of chiral units, you cannot go for the first generation. So अब मुझे बताइए first generation के relation में कोई query आपको है? Is it understand? After this lecture I am going to ask, because this is a tutorials, you have to participate in it. Okay, so in first generation you know that is a substrate control. Now comes that if my substrate doesn't have any chiral unit, करेगा. Here we are just talking about the getting of one product. Okay, but which one, whether it is from the above, whether it is from the below, this comes with the different auxiliaries. Okay, so it is the blockage. Okay, if we have to answer his question also, I said I have locked this door but I have opened it. I can do the reverse also. If I don't mind that students are going outside from that side, I just close it. I am teaching at the podium, any student can come and he or she can sit. What is the problem? It is only what I have required, what is my desire. So that I am going to explain in evening lecture or morning, where we are talking about phase blocking. Here we are saying out of the two we have to just block one. Okay, but next is which one? It also depend as per your requirement कि आपको जो अब in this molecule, in this product, can you see methyl and methyl are on the opposite side? But if I just want to choose the methyl on the same side, I have to take the substrate as a reverse one. Okay, so whatever the transition state is going to form, that we will have to discuss as per our preference. For that there are different auxiliaries are present. Okay, So if first generation is okay, we are moving to the second generation. Now can you see in second generation what is the substrate? Palvi, क्या substrate है second में? cyclohexanon. Okay. Now in this substrate आपको कोई chiral unit दिख रही है? We don't have any chiral unit. Then who is going to control the attack of the incoming group? Okay. So what we are doing, अगर तो chiral pool में आपके पास substrate में chiral unit मिल जाए तो best है, अगर नहीं मिला कोई बात नहीं, we move something else. So that something else is auxiliary controlled. So what we do in this, the chiral directing group, the chiral auxiliary is deliberately attached to the achiral substrate, which is removable after it has served its purpose. आपने फर्स्ट जनरेशन में क्या देखा कि कार्बोनाइल के एडजेसेंट पे दो ग्रुप प्लेस्ड हैं, एक हाइड्रोजन है और एक मिथाइल है. दे मस्ट बी डिफरेंशिएटिंग, तभी आप उनका यूज कर पाओगे. तो उन ग्रुप का काम क्या था? क्या उन्होंने केमिकल रिएक्शन में कोई पार्टिसिपेट किया? नहीं. उन्होंने तो फेस को, प्लेन को डिफरेंशिएट किया. कैसे डिफरेंशिएट किया? एक साइड मिथाइल है, दूसरी साइड हाइड्रोजन है. ओके. सो दोनों ग्रुप डिफरेंट है, तो दोनों की स्टेरिक इन्वायरमेंट डिफरेंट है. सो आपने दो प्लेन को डिफरेंशिएट किया फॉर द इनकमिंग ग्रुप. सो अगर हमारे पास सबस्ट्रेट में कोई ऐसे ग्रुप नहीं है तो हम अपने सबस्ट्रेट में ऐसा ग्रुप प्लेस कर सकते हैं टेम्परेरीली, ताकि वो दोनों प्लेन्स को डिफरेंशिएट कर सके. व्हेन इट डिफरेंशिएटेड द बोथ प्लेन्स, you perform the reaction, and once the reaction is over, you remove that auxiliary, you will get your final product. So if you see the scheme, that if your substrate, you place the A star, that is the auxiliary. Once you place the auxiliary, then you bring your reagent, a chiral reagent, then that reagent is going to add with respect to the auxiliary which is present. Once it is, your product is formed, remove the auxiliary. Now can you see in your reaction, that is cyclohexanon, you react with it phenylallanol, get the chiral auxiliary product. Now what is this? What is this big structure? In a very simple way, कार्बोनाइल को अगर आप अमीन से रिएक्ट करें तो क्या बनेगा? If I have a aldehyde or if I have a amine, what will you get? I guess up in your laboratory you get many papers that you are preparing Schiff's bases. You are treating aldehyde and amine, getting carbon nitrogen double bond. So that's mean they are complementary group. Okay. So you find a substrate and the appropriate complementary group, chiral complementary group, and make the auxiliary on the substrate. So starting हमने क्या लिया? That is cyclohexanon. उसमें आपने phenylallanol लिया, you get carbon nitrogen double bond. Now the question is come, how this auxiliary has to behave? It should be a simple one or it should be a very crowded one? मनरीत क्या होना चाहिए? It should be crowded one. अगर मैं आपको कहूं that define the whole asymmetric synthesis in one word, तो आपने क्या कहना है? नॉन इक्वलेंस. अच्छा, मैं आपको बड़ा सिंपल एग्जांपल देता हूं. इफ यू हैव टू रिकॉर्ड द NMR स्पेक्ट्रा ऑफ इथाइल अल्कोहल, हाउ मेनी टाइप्स ऑफ पीक्स यू आर गोइंग टू गेट इन स्पेक्ट्रा? इथाइल अल्कोहल में NMR स्पेक्ट्रा में कितनी पीक्स आपको मिलती हैं? बट आई एम सेइंग उसमें तो हाइड्रोजन ही है, व्हाई यू आर गेटिंग 3 पीक्स? If the atom is similar, CH3, CH2, OH, but why you are getting 3 different peaks? Because you are saying that all the 3 hydrogen have a different environment with respect to each other. So if with the same atom you are going to create a different environment, you are going to get a different peaks. That's mean you are going to get a differentiation. So similar is the case with asymmetric synthesis, because if you are talking about symmetry, it is 50-50, there is no issue, you are getting all the enantiomer in equal ratio. But if you want to create a asymmetry, that's mean you must differentiate the plane which is above and plane which is below. So that differentiation, that non-equivalence should be there. So how you create a non-equivalence? You are putting a group, a bigger group. So if a bigger group is either present above the plane or below the plane, you don't have to figure out that in final product why this configuration. Just remember here that you are distinguish the two planes for the incoming group. Okay, so what you are doing? In substrate you are going to add one group in such a way that it can create a huge crowding towards one plane, so that the incoming group feels discomfort. Okay, it feels such a discomfort that it try to prefer to come from the other side. Okay, if I am standing here, anybody is coming late after 5 and 10 minutes, I am scolding him or her, but in that side nothing is going to happen, nobody is there, you can come easily and sit from where you want to come. You want to come from this side? जहाँ पे मैं खड़ा हूँ आपसे पूछ रहा हूँ लेट क्यों आए, ऐसे क्यों आए, मैं तुम्हें अंदर नहीं आने दूंगा, so many things. But in that side you don't have any issue, door is open, you are coming at 9:15, come and sit and enjoy the topic. What is your preference? You want to go from that side. Similarly, if in the plane you are creating such a crowdness, bulkiness of the substituent on one side, why the incoming group try to enter from that side? It try to enter from the opposite side where there is no steric crowding or any issue. So if it is preferably coming from the other side, your objective is reached, that you block one face, open the other face, your enantio selectivity and enantio specificity already increased. Okay, so in this case you place the auxiliary, आपने सेकेंड स्टेप में ऑक्सिलरी प्लेस कर दी, उसके बाद आपने रिएक्शन शुरू किया. व्हाट इज द रिएक्शन इन दिस? आपने क्या ऐड किया हुआ? बेस. इफ यू सी, आई जस्ट मार्क दिस इज आर स्टार. दिस आर स्टार और ए स्टार इज ब्लॉकिंग एनी फेस. डोंट गो वाई अबव वाई बिलो, जस्ट सी इट इज ब्लॉकिंग वन फेस. नाउ व्हाट इज द नेक्स्ट स्टेप? You are bringing the base. What a base will do? It will abstract the proton. This base is abstracting the proton. You will get a negative charge here which is delocalized in this system. Now you treat your reagent. Okay, that is going to come. Now the reagent is coming from which side? Where you don't have this phenyl HCH2OH group. It is coming from the side which is away from the steric bulk. So you are getting the target product. So that is your pair of diastereomers. Now can you see, in the presence of auxiliary you have a two stereogenic center. रेजोल्यूशन स्टेप यहां पे अप्लाई हो सकता है। आप